Hello everyone, in this video we'll be doing the CBSE Class 9th Maths Chapter 2 Introduction to Linear Polynomials. This is as per the new syllabus and textbook Ganit Manjari. Let's get started. Let us understand what are polynomials. Consider a basket of apples and we don't know the number of apples in this basket. So let us say there are X number of apples in this basket. Let us say there is another basket with watermelons, and again we don't know the number of watermelons in the basket, so we will say there are Y number of watermelons in this basket. Now let's say I take 4 baskets of these apples and 3 baskets of these watermelons and additionally 2 more mangoes and give it to Ria. What are the total number of fruits that are present with Ria? Well, we already discussed that number of apples are X, number of watermelons are Y. So the total number of apples will be 4 baskets, so 4 times X, which is 4X. The total number of watermelons will be 3 baskets and number is Y, so 3Y. And we have 2 mangoes. So the total number of fruits will be 4X plus 3Y plus 2. This expression 4X plus 3Y plus 2 is called a polynomial or an algebraic expression, where 4x and 3y are called the terms of the polynomial and x and y are the variables of this polynomial which keep changing. 4 and 3 here are the coefficients of these variables and 2 in the end is a constant which never changes. Now, if in the example here, if I had given 2 crates of mangoes to Ria, in which I don't know the number of mangoes and let's say that is z, then we have a polynomial in 3 variables, something like 4x plus 3y plus 2z. And in the example that we saw where it was just 2 mangoes, it is a polynomial in 2 variables, 4x plus 3y plus 2. And if there were no watermelons and I had just given 4 apple baskets and 2 mangoes, it is a polynomial in 1 variable, which is 4x plus 2. In this chapter, we will be dealing with only polynomials in 1 variable. Now, the highest power of the variable in a polynomial is called the degree of the polynomial. If I write a polynomial saying 4x cubed plus 3, the degree will be 3. And since the degree is 3, it is called a cubic polynomial. If I write 4x square plus 2, the degree is 2, which is a quadratic polynomial. And if it is 4x plus 1, the degree is 1, which is a linear polynomial. In this chapter, we will be focusing on linear polynomials in 1 variable. Let us see what happens when there are multiple powers. So if we have 7x cubed plus 2x square plus 10x plus 6, the degree will be still 3 because we have to go for the highest power of the variable. And what if there is no variable? We have a constant like 15. The answer is 0. The degree is 0 here because 15 can be written as 15x power 0. Hence the degree of the variable is 0. Let us try to solve these polynomials and see what happens. So let's say the total number of fruits with Ria are 18. So how many apples will she have? So we already formulated it as 4x plus 2 because she had 2 mangoes and 4 baskets of apples. So 4x plus 2 will be 18 and 4x will be equal to 18 minus 2, which is x is equal to 16 by 4, where x will be equal to 4. So 4 is the number of apples in each basket. So the total number of apples with her is 4 into 4, which is 4 baskets into 4 apples in each case, which is equal to 16 apples in total. So this is how we can solve a polynomial. Considering another example, a present age of Salil's mother is 3 times Salil's present age. After 5 years, their ages add up to 70 years. Find their present ages. So let us consider Salil's present age as x. So if Salil's present age is x, Salil's mother's age will be 3 times x. So it is 3x. After 5 years, both their ages increase by 5 years. So Salil's age will be x plus 5 and Salil's mother's age will be 3x plus 5. Adding these two, the ages will be 70. So x plus 5 plus 3x plus 5 is equal to 70. So solving this further, we can only add 2 variables. So adding the both variables, we get x plus 3x, 4x. And adding the constants, 5 plus 5 is equal to 10. So 4x plus 10 will be equal to 70. 4x will be equal to 70 minus 10, which is 60. And x will be equal to 60 by 4. So x finally will be equal to 15. So Salil's present age is 15. So the mother's age will be 3 times x, which is 15 into 3, which is equal to 45. This is how we can solve linear polynomials or equations. Moving on to linear patterns. A linear pattern is a sequence of numbers where the difference between them is always constant. So let us consider an example here to understand this better. So let's say there is a bank which says that if you deposit 2000 rupees today, we will give you 20 rupees per day as interest or income for the number of days the amount is in the bank. So a person decides this is the best way to make more money and he deposits money here. So what is happening here? So on day 0, the amount that you have in the bank is 2000. On day 1, another 20 gets added, it becomes 220. Day 2, another 20 gets added, it becomes 240. Day 3, 260. And day 4, 280 and so on. So on the nth day, what is happening? The amount on each day is increasing by 20, right? And from the first day, it was increasing by 20 into the number of days it is present. Like it increased by 40 on day 2 because that is 20 into 2. So 20 into the number of days it is present. So on the nth day, it is 20 into n days, which is 20n, and this 20n gets added to the initial amount 2000. So finally on the nth day, we have 2000 plus 20n. This is a linear pattern where each part of the sequence, that is 2000, 2020, 2040, 60, go on forward, increases by the same amount of 20. This 2000 plus 20n is called a linear relationship between the number of days and the total amount. Let's say a person wants 2340 rupees. So for how many days should he deposit this amount so that he gets this amount? So we can equate this relationship to 2000 plus 20n to 2340 and solve the equation where 21 is 2340 minus 2000 and n is equal to 340 by 20, which gives n is equal to 17, to find out the number of days he needs to put this money so that he gets the amount. And this is called a linear equation. And if we write that amount after n days is y and the number of days as n, and we can write it as y is equal to 2000 plus 20n, this is becoming a linear function where n is an input and the processing unit does this function of 2000 plus 20n and gives the output of y. So if you give different values of n, you get different values of y correspondingly. This is a linear pattern with a linear function involved. Let us take another example here where you say there is a wellness center and they say if you join us and you eat healthy and exercise every day, you can lose up to 2 kgs per month. So the person with 120 kgs walks in and wonders how many days that he has to work out to reach his ideal weight of 70 kgs. So let us put this in the form of a table. On 0th month, he'll be at 120 kgs. The first month, he will lose 2 kgs. He'll be at 118. Second month, he'll be 116. Third month, 114. Fourth month, he'll be 112. And last month, or the mth month, he will be 120 minus 2 times the number of months, which is m. And if he wants to reach his target weight of 70, he has to work out for 70 equals to 120 minus 2m, where 2m is equal to 120 minus 70 and m is equal to 50 by 2, which is 25 months, or 2 years and 1 month. So if he works out for 2 years and 1 month, he will reach his target weight, which is also a healthy way to lose weight. Moving on to understand what is linear decay and growth. We saw 2 examples here. One where the money grew. Each day as you kept adding, the money grew by 20 rupees. The other is the weight loss program where the weight reduced over time. So whenever there is a growth in the number, that is the sequence continues to grow or value increases, it is called linear growth. And whenever there is a reduction in the number where the value continues to decrease, it is called a linear decay. Right? So let us solve some examples to understand these better. Sarita is reading a book of 500 pages and she reads 20 pages every day. How many pages will be left after 15 days? Express this as a linear pattern. So Sarita is reading the book. So let's say the number of days are written above. So 0th day she starts. There are 500 pages left. On day 1 she reads 20 pages. So 500 minus 20, 480. Day 2, another 20 pages are done, so 460 are left. Day 3 is 440 and day 4 is 420. Like that, after 15 days, she will lose 500 minus 20 into the number of days she has read, so that is 15, which is equal to 200 pages will be left after 15 days. This is a linear pattern. Moving on to another question. The initial population of a village is 750. Every year, 50 people move out of the village. Find the population of the village after 6 years. Make the table of the values of t varying from 0 to 10 years and show how the population decreases every year. Find the expression that relates p and t and explain why this represents a linear decay. So if the initial population is 750 and the change every year is 50, it is reducing by 50. For 6 years, what will happen is we have to subtract 50 6 times to find out the final population in 6 years. So 750 minus 50 into 6, which is 750 minus 300, is equal to 450. So this is the amount of population after 6 years. Now the table would look something like this, where 50 people get removed every year, and by the 10th year you will have 250 people left in the village. Now the expression that relates this is what we had written earlier. Population will be 750 minus 50t. And this is a linear decay as the sequence value continues to reduce over the years. Moving on to linear relationships. Let us write all the linear equations that we have written so far. We first started with fruits. Number of fruits were 4x plus 2. Then we started with the amount deposit, which was 2000 plus 20n. Then we did the weight loss program, which was 120 minus 2n. Then we did the number of pages left, which is 500 minus 20 days. And the population, which is 750 minus 50 into t. Now this is in the form of y is equal to ax plus b, where x and y are input and output of this function. We can always find out the relation between x and y by finding out what is a and b. So all we need is two values of x and y, which can help us find the relation between them. Let us see an example to understand this better. So if a person takes an auto ride, and whenever he rides 5 kilometers, he ends up paying 55 rupees. And for a ride of 2 kilometers, he pays 25 rupees. So what is the relationship between the fare that he pays and the kilometers that he has traveled? So when x is 5, y is 55. So and x is 2, y is 25. So if I have to write this in the form of y is equal to ax plus b, the first equation can be written as 55 is equal to 5a plus b. And the second statement can be written as 25 is equal to 2a plus b. Now I can write from here b is equal to 25 minus 2a. And if I substitute this b into the other equation where 55 is equal to 5a plus b, I can say that 55 is equal to 25a plus the b part, which is 25 minus 2a. So now putting all the variables on one side and constants on the other side, 55 minus 25 is equal to 5a minus 2a, where 30 is equal to 3a and a will be 30 by 3, which is equal to 10. Now I substitute this value of a into the equation of b that we have written, where b is equal to 25 minus 2a. So I write b is equal to 25 minus 2 into 10. So b will be equal to 25 minus 20, which is equal to 5. So now we substitute the values of a and b into the yx plus b. So we can write y is equal to 10x plus 5. So the base fare is 5 rupees, 0 kilometers is 5 rupees, and for every kilometer he is charging 10 rupees. That is what is the relation between x and y in this situation. Now if we visualize this linear relationship y is equal to ax plus b, it is the equation of a straight line, where a is the slope of the line and b is the y-intercept, or where the line touches the y-axis. So if we have a bunch of values for x and y for an equation like y is equal to 2x plus 1, and I have some values of x and y, like when x is 0, y is 1, when x is 1, y is 3, and when x is minus 1, y is minus. Plot these points on a graph and I connect them with a straight line. That is how I can visualize a linear relationship on a straight line. Now let us see what happens if we change the values of a and keep b constant. So I can take y is equal to 2x plus 1, and we have y is equal to minus 2x plus 1, where I've changed the value of a. And I can take y is equal to half 2x plus 1. I have again changed the value of a. And if I plot all these three lines on the graph, it will look something like this. And we can see that if we change the values of a, keeping b fixed, the slope of the line changes while the y-intercept remains fixed. And now if we do the other way around, that is if we keep changing the y-intercept and keep the slope constant, that is, let's take y is equal to 2x plus 1, y is equal to 2x plus 3 and y is equal to 2x minus 2. And I plot this, we get a bunch of parallel lines. So if we change the value of b, keeping a fixed, the lines will shift but remain parallel to the original line. So they always remain parallel to the original line. This is what is visualizing linear relationships. So whenever you see a bunch of equations where the y-intercept is changing but the slope remains same, you know that they are parallel lines. And if the y-intercept is same, they are fixed at a point and they keep turning about that point. So this completes the chapter Understanding or Introduction to Polynomials. Comment below if you want me to find solutions to all the exercise problems in the NCERT textbook. Like this video, subscribe to the channel, and we will see you in the next one.